Hey guys, I wanted to do an answer key for the Unit 1, Topic 1, SLT1 through 2 homework. There's 2 homeworks in this packet. There's 5.1 and 5.2, and then there's 8.1 and 8.2. Alright, those are the 2 homework assignments that are due, and I'm going to just put them both into one video, I think, because they don't take too long. So let's get going. So number 1 is asking how many undefined terms are there in geometry, and we know there's only 3. And then number 2 is asking you to name them and draw them. So we know that the first one is point, and we always represent a point just with a dot, and we name it with a single uppercase letter. Next is a line. And we represent a line with, well, a line, of course. And we make sure we put arrows on both ends to show that it runs on forever. And we can name a line 2 different ways. We can either pick 2 points on the line, or we can mark it with a single lowercase letter that's in cursive, like this M. So this could be line BC. Now when we write line BC, we put the hat on it like this. Now, if we name it by the lowercase letter, then we write the word line and then the lowercase letter m. So that's 2 different ways we could name that. And finally, we have plane. That's our 3rd undefined term. Planes can be named 2 different ways too. You can name them either with an uppercase cursive letter, usually P for plane, but it could be other letters. Or you could name it by 3 points in the plane, but you got to make sure those 3 points don't all lie on the same line. They have to be non-collinear points, meaning essentially they have to form a triangle. So what do we got? A, B, C. This would have to be D, E, F. So if you name the plane by the 3 points, then you write the word plane, and they're all points, so they're all uppercase, D, E, F. So that's one name. The other way to name it is write the word plane and then use that single uppercase cursive letter. So plane D, E, F, or plane P. So there's all the undefined terms named and drawn. Here we're getting into notation. Notation can be a little weird in geometry. So they're asking you to name segment AB. Well, to name segment AB, the obvious answer is this one here, AB. Because it's a segment, it doesn't go on forever. It's only the part of a line that lives between these 2 endpoints. So when you put the hat on it, you don't include arrows. You don't want to. Now, you also can use BA, because reversing the letters doesn't matter. It doesn't matter if you name it AB or BA. So that's 2 down. We might use these again, but I'm going to go ahead and cross them out. I don't think we do. All right, next they want ray AB. So ray AB is the part of a line that starts at A and passes through B, which means it has an endpoint at A, but after B it runs on forever. So the symbol for that, well, it looks just like it. We pick AB and we use a hat that shows that A is the endpoint and B is the point we run through, and we go past B and we keep going forever. So that's the symbol for ray AB. And ray BA would not work. You can't change the order, because ray BA, you guys can see, would start here with B as an endpoint, and it would pass through A, and clearly that pink ray is not the same as that green ray. So now they want line AB. That could be AB with a line hat on it. And using the same A and B down here, we can see that in purple, as long as you pass through A and B and you run on forever in both directions, that purple thing's our line. So if we said BA and we put a line through B and A, it would still be the same line. And so this one does have another name where you just reverse the letters and say BA. So that's an acceptable answer that we used. There's BA. I think we already said this one here is like not getting used. So now they want the length of segment AB. To represent the length of segment AB, you just take the hat off of it. And suddenly that's the length of AB. And since AB could also be called BA, then BA without a hat is also acceptable. So we did what the instructions said. They said use all but one, and we did. The one we didn't use is ray BA. So that's it. I should point out though that saying BA with no hat as the length of BA, you can also say BA, keep the hat on it, but put a little M in front. And now that stands for the measure of segment BA, meaning the length of it. So that's just some notation stuff. Hopefully that's clear. Now 4, there's a bunch of questions here. We've got sort of a complicated diagram up here. There's a plane that seems to be called W, a line segment getting intersected by another line segment. And then we've got a line that seems to come down from above the plane, and then it pierces the plane, passes behind the plane. That's why it's shown dashed here. And then it comes out the other side. So let's answer the questions they're asking. It says, write 2 names for the given plane. Well, one name was to pick 3 points that are in the plane, making sure that they don't all lie on the same line. So you can't say plane AMB, because they're all on the same line. We want 3 points that make a triangle, so, I mean, ABC is fine. If you just picked ABC, that's great. So plane ABC. And of course, the other possible method for naming a plane is to find that one letter. Now that letter should really be cursive. So I'm going to go ahead and fix that. Let's just kind of erase the, ooh, that's not the right color. That's okay. Now it's the right color. So now that W is gone. When you're naming a plane, it has to be cursive. So our W should be more like ba-doop, 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 whoop, and put a little tail on it. But now, if we call it plane W with a nice cursive W, I know that's not a real cursive W, by the way. What is a real cursive W? I think it's like, I actually have no idea. It probably loops in the middle. Who cares, right? It doesn't matter. I don't care about cursive, but you have to put some kind of tail or something. Something that lets me know that you're trying to do cursive. And if it's not really the right cursive, I don't care. Anyway, that's it for naming the plane. You don't have to use this other method, by the way. If you said plane ABC, and then you also said plane ABD, and just picked a different point, that would be great. Anyway, it now says name 3 collinear points. So I already pointed out A, M, B as being collinear. R, S, and T are collinear. C, M, and B, and C, M, and D are collinear. Pick any of those. It doesn't matter. I'm just going to go with A and B. The one thing to remember, of course, is when you're naming 3 separate points, you gotta include parentheses to show that you're talking about 3 separate points rather than naming a plane or naming a triangle. When you name the plane, notice you should not have commas. You're not trying to separate them out, but down here you are. So now it says name 3 non-collinear points. That means just pick points that don't all lie on the same line. Again, a good way to think of that is, do they make a triangle? So something like BMD. Those are certainly non-collinear. I'm going to go with those. So comma, comma, period. There's my list. Now it says name a set of points that is coplanar. So coplanar means they all lie on the same plane. So I see A, B, C, D, M, and S all live in this plane. R is up above the plane, T is down below the plane, but you can pick any of the, when you're naming non-coplanar points, you really should be giving me at least 4. I would just go A, B, C, D. That seems to be the easiest way. Pick the 4 that are right in the plane. Okay, that's what I'm doing. Basically, just don't go with R and T. Everybody else is in the plane except for R and T. Now it says name 2 rays. So to find 2 rays, well, I could start at S and go through R. So SR seems like a great little ray. And then I could start at S and go through T, or I could start at R and pass through T. And I could even start at T and go through R. Because remember, SR is that kind of short ray that starts at S. But if I start at T and go through R, that is naming a completely different ray. So maybe I'll do that. Let's go with TR. And then these are 2 different rays. Now it says name the intersection of the plane and the line. Well, the intersection of 2 geometric objects is whatever points they share. It's whatever points they sort of meet at. That's what intersection means, right? It's where things cross. So looking at where the line RT, where the line meets the plane, is right there. It's at point S, and that's it. The intersection is the point called S. Now it says name a segment that does not lie in plane W. Okay, well, I could say SR, I could say ST, I could say RT, because to lie in plane W means the whole thing has to be in plane W. So the fact that RT intersects plane W doesn't mean that it lies in plane W. So I'm going to go with RT. RT is a great segment. When you're naming a segment, make sure you put the right hat on it. Up here you are asked to name a ray, so make sure you use the ray hat, right? That you have to use the right hat based on what you're asked for. But that's it for 4. For number 5, it says, are points A and R collinear? It's kind of a silly question because when you're only given 2 points, the answer is always yes. 2 points will always be collinear no matter what. Okay, I think they're asking this question because it's tricky, because when you find A and R, you don't see a line that joins them. So a lot of people probably say no to this question even though the answer is yes. They're collinear as long as you can draw a line that would include them both. And this line here that comes running down through R hits A, it would go behind the plane for a second and come out the other side and go behind it. But since they do both lie on line AR, they are collinear. So are they collinear? You should be saying yes, even though you couldn't see the line. The answer is yes because you can draw your own line. I guess let me say more about collinear. That's as opposed to if we had said, hey, are points A and M and S collinear? At that point it's clearly no, because if you try to draw a line through A and M, then you're not going to hit S. You're going to keep going that way. You're going to miss S. The only way to make a line go through A and M and S is to curve the line. And you can't curve lines. Lines are supposed to be straight, of course. So, A and M and S are a good example of what non-collinear points look like. Now part B says, are points A and R coplanar? And again, it's another dumb question, because before you could be non-coplanar, you would have to actually give 4 points, because any 3 points will always be coplanar. Always, always, always. So the answer to this, again, is clearly yes. But let's make this slightly more interesting. They said A and R. Well, we could have said A and R and S, and those would still all be coplanar, because A and R and S form a triangle, and maybe you can visualize what that triangle looks like, and then imagine extending that triangle outwards. That triangle defines a plane that contains point A and R and S. So it's definitely a yes. Let's keep going. It says the tick marks show. The tick marks, if you don't know, are the little marks on lines that show that they're congruent. So it's this mark here, slash, slash. Since both of those line segments have tick marks, it means they're congruent. If they're congruent, it means they have the same measure. So we're going to go ahead and say that the length of AM, meaning we just don't put a hat on it, and I wrote the wrong letter by accident, excuse me, AM, right, is going to be the exact same as MB. And because those lengths are the same, it means we can say that AM, the line segment, is congruent to MB, the line segment. It might feel redundant, but up here I'm saying that the measurements are equal. Down here I'm saying that the two figures have the exact same size and shape. Equal and congruent are not really the same thing. Anyway, because those two chunks are congruent, that tells me that point M is the midpoint of segment AB. The midpoint means, obviously, the point that's right in the middle. It means it's the point that cuts the segment into two smaller segments that are both congruent to each other. That's what a midpoint is. Now it says CD is the blank of AB. Well, since CD is a line segment that's cutting AB exactly in half, it's called a bisector. Remember, to bisect is to cut into two congruent parts. And so CD does that to AB. It bisects it. So it's the bisector. And that's going to do it for number 5. For 6, you have a little bit of algebra. So read through, find some important vocabulary. It says point M is the midpoint. So again, we've got that midpoint idea. If it's the midpoint, it means that we're dividing this line segment in half, so AM has to be the same as MB. That's what I know. I know that AM must be equal to MB because M was a midpoint. Now I see information that says that AM is 40, so I can just substitute that 40 in. Then I see that MB is 5x plus 5, so I can plug that in. And now I've got a simple algebra equation that I can solve. If you want to isolate x, you're going to subtract 5 from both sides first. You always get rid of the whole number before you get rid of the variable values, okay? So you get rid of that constant on the end before you get rid of that coefficient. So subtracting 5 cancels the 5 over here. And when you subtract 5 from 40, you get 35, of course. So now we have 35 equals 5x. Now to get x alone, we got to get rid of that 5 that's a coefficient. And since we're multiplying by it, the opposite thing to do would be divide by 5. And I'll do it on both sides. Here the 5's cancel, leaving me with just plain old x. And here when I divide, I get 7. So I know that x is 7. And I think that's all you were asked for, right? But typically in geometry, there'll be a follow-up question where I might also say to you, well, okay, now you got to find me the length of MB. And there's two ways to do that. I'll give you the hard way first. The hard way is to recognize that MB has this algebraic expression. So if MB is equal to 5x plus 5, then we can plug in the 7 that we just solved for. Excuse me. We get what? 35 plus 5, which makes it 40. And as soon as you see that it's 40, maybe we start to feel silly because they already told us that AM was 40. And then we knew that MB had to be the same. So of course they were both 40. So AM's 40, MB's 40. So if I asked you for the length of the whole thing, you just add the 40s and get 80. Okay, forgive me, I had to pause the video to cough for a second. But I'm back and we'll do 7 now. It says segment AB bisects segment CD. Again, to bisect means to cut in half. So if AB is cutting CD in half, then N must be the midpoint, and CN would be the exact same length as DN. So we're going to approach this one similarly to how we did the last one. So CN has to be equal to ND. And then we see that CN is 5y plus 2, so we can substitute that in. And ND is 52. So again, we're just going to do algebra. If you want to get the y alone, then you're going to always add or subtract before you multiply or divide. So to get rid of the 2, we'll subtract 2, and we'll do that first. Cross that out. You get 5y, and now it's equal to 50. So now we can divide to get rid of the 5. The 5's cancel. We see that y is 10. And we can stop there. What do we know? It said ND is 52. That would mean this other chunk is 52. That would mean the whole thing is 104. So if there were any follow-up questions about solving for those other pieces, hopefully you guys understand how to do that too. Let's try 8. Oh, there is no 8. So instead we get to homework 8, which is the second homework assignment. And this one is all about angles and angle measures. So we can run through this one. It's asking, name the vertex of angle 5. So hopefully you remember. We talked about an angle, we defined it as a ray, and then another ray. And what you do is you make sure that those two rays have an end point in common. So you set it up like this so that they share that same end point. And then of course I could rotate this to make the angle bigger or smaller. But that's the deal. We said an angle was two rays with a common end point. We also said that the common end point, the end point that the two rays shared, that was called the vertex of the angle. So you're looking for that point there when they ask you to find the vertex. And they said angle 5, so you find where it says 5. And clearly angle 5 is trying to be this angle that I'm highlighting in red. And so we can see that the vertex of it is point E. So that's easy peasy. Now it says name the sides of angle 4. And angle 4 is up here. It's got its vertex at A. One of its sides runs through T, so there's that ray. Its other side runs through E, so there's that ray. So if we're naming the sides, then we're naming those two rays. The first one is ray AT. Put the right hat on it. And the next one is ray AE, or AS. We could name it two different ways. I'm going to name it AE, because who cares? Either one is fine. But that's how you name the rays to name the sides of an angle. Now, in problem 3, they want us to be giving alternate names for some of these angles. So you got to just look where they are, find them, and see if there's other points that you can use to give them a name. So when they say angle 1, that's this guy here. Now we know that we can't just call it angle L. If we call it angle L, well, angle L could be angle 2 for all we know. Angle L could even be angle ALS for all we know. So I don't know. If I want to rename angle 1, I have to use that method where I use 3 points. So since angle 1 has a ray that passes through A and another ray that passes through E, and since its vertex is at L, one good name for angle 1 would be to name it ALE. So that was no good, but angle ALE is great. Now to rename angle 6. I don't know why that is not erasing super well. So we find angle 6. There it is. And angle 6 has its vertex at E, but we still can't just call angle 6 angle E, because angle 5 also has its vertex at E, and that would get confusing. So again, to name angle 6, really the only way we can do it is by using points that lie on the rays that form angle 6. So we definitely got to use E, because we always use the vertex and we always put it in the middle. For this ray, the only other point we can see is S, so we have to use S. And then for the other ray, we've got a choice. We can use D or L. So we can either be DES or LES. Let's go with LES. There. So that's another name for angle 6. Angle LES is angle 6. And then they're going to go the opposite way. They're going to give us the 3 points to name an angle. This thing's just small. That's better. So ATS. So if I start at A, and then I move to T, and then I run to S, then you guys can see that from A to T, T to S, we're talking about this angle right here, which we could just call angle 8. So I will. We could have also named it what? Angle DTS. We could change letter A to D, and that would be fine. We could also just reverse it, say angle STA, and that would be a right answer. But that's going to do it. I would go with 8. I would go with AL for that one. I would go with LES for that one. We're good. All right, now it just says state whether the angle appears to be acute, right, obtuse, or straight. So you just look at the angle and you eyeball it. It says LAS. So L to A to S is this whole thing. I think a lot of people said that looked like a right angle, and it does. It does look like a right angle. But if I cheat a little bit and draw like a square, a nice bright square, you know that the angles of a square are exactly 90. And if I hold this up for comparison, oh crud, I'm back. If I hold this up for comparison, then you will find that our angle is too small. Is that lined up quite right? Not perfectly. Maybe this is taking too long. Okay, let me now make that kind of see-through. Now that that's see-through, you can see that our angle is just a little bit less than 90. It is kind of hard to tell, I admit, But now that I've put this square here, you can see what 90 really looks like, and you can see that our angle is a little less than 90, and that means it's acute. Now, for angle EDT, we're going from E to D to T. This one's a lot easier to eyeball. From E to D to T, it's this angle here. We can all see, I hope, that angle for sure is bigger than 90 degrees, which makes it obtuse. And lastly, they're asking us about angle ATL. So here's A, down to T, over to L, and they went through a lot of trouble to actually show us that little box. And if you didn't know it already, that box is the symbol for a 90-degree angle, a right angle. So we know that this angle is a right angle. And that's it for that. Let's move on to number 5. So 5 is asking why is it confusing to refer to angle A, and you actually have to, answer that in words. So you'd say something like angle A. Could refer to either angle 3 or angle 4 or angle LAS. So the reason it's confusing is because, well, there's 3 different angles that all have their vertex at A. So if all you said was angle A, I wouldn't know which angle you're talking about. So you're not allowed to use that. You can't use that name. You can't say angle A. However, if you look down here at angle 7, you could say angle S, and everybody would know who you meant, because there's no other angle that has its vertex at S. 7 is the only one. So if we wanted to call angle 7 angle S, we can. Now what does part B say? It says name 3 angles that have A as their vertex. Well, actually I just did that up here. It was angle 3, angle 4, and angle LAS. I'll just write it again. Angle 3, angle 4, and angle LAS. Alright, now they're saying name 2 angles that form a linear pair. If you don't remember from the notes, we said a linear pair was 2 angles that are adjacent and also supplementary. So you might remember that adjacent means that if you've got an angle that's adjacent to it has to share the same vertex. They have to share a ray, so these 2 rays should be the same ray, and then the other ray can shoot off like this. So here angle 1 and angle 2, those are adjacent angles because they share the vertex, they share a ray, and they don't overlap. But to be a linear pair, you have to be adjacent angles and you have to be supplementary. So to be supplementary means that you've got to form a straight line. So imagine if I took this ray right here and extended it so that I knew I was working with a perfectly straight line. Well, then I could delete this ray and call this obtuse guy angle 1. And then I would know for a fact that since these guys are adjacent and since these rays form a straight line, I would know that angle 1 and angle 2 added up to 180. That makes them supplementary. That's a linear pair. So looking at our diagram, where do you see that? Here is the place that stands out the most to me. Angle 5 and angle 6 have rays that form a nice straight line. So they're supplementary. They're adjacent. They're our linear pair. Angle 5 and angle 6. For bonus points, find the other linear pair. It's right here. It's angle 8 and this angle here that's marked with the box. It's not numbered, so you'd have to name it what? ATL, I guess. So let's say or angle 8 and angle ATL. You don't have to give me both, of course. I'm just mentioning both, so that if anybody had this answer, they wouldn't think they're wrong when I say 5 and 6. Both of those answers are right. Moving on to 7. 7's going to start throwing some algebra at you. So as long as you read the question and see this keyword of supplementary, supplementary means they add up to 180, right? So it says given angle A and angle B are supplementary. Well, we'll take a and b. We'll take those algebraic expressions. And we know that the 2x from angle A plus the x minus 15 from angle B, those are the angle measures. They must add up to equal 180, because that's what it says. So now you just do your algebra. You definitely take your x's and you combine them first. It says do 2x plus x. That'll give us 3x. The minus 15, we just bring that down. And the equals 180 will bring that down. Now we have a slightly simpler equation. Let's solve that by getting rid of the 15, by adding 15. We'll do that on both sides. Here they cancel, so the only thing left on the left is 3x. And over here, add that up, you get 195. Now, to get rid of the 3, you divide by 3. That gets these 3's to cancel, leaves me with x. And then what is this? 3 goes into 19 6 times 65. So the answer is 65. Find the value of x. Now there is more to it, because it says also find the measures of the angles. So we know that we're not done until we also find the measure of angle A and the measure of angle B. So we know that angle A is just 2x. That means it's 2 times 65. That means it's 130. Now to find angle B, we shouldn't have to do any work technically, because we know they added up to 180. And 180 minus 130 is 50. But we gotta show work, or we don't get credit on our assessments. So what's one way to get the 50? Well, we know that angle B is the x minus 15, right? Here's the expression. Oh no. My pen does that sometimes, excuse me. But for angle, oh, still doing it. Okay, cut it out. You done? It's done. Okay, so this time the measure of angle B, it's x minus 15. That means we can substitute in for x, the 65. Remember we solved and got 65? So subtract, and 65 minus 15 is 50, like we said. So there's certainly a fast way. If you already know A, you just do 180 minus A, and you get 50. A longer way is you take the expression that represents B, you substitute into it, and you get your final answer. So that's it for 7. Here's 8. It's more of the same, except this time instead of the angles being supplementary, they're complementary, and that means this time they only add up to 90. So let's take our two expressions. If C and D are are complementary, that means they add up to 90. That means that the y minus 8, I can add that with the 3y plus 2. And I know the result is supposed to be 90. So we've got our equation, and again, to solve it, the first thing we should be doing is combining like terms. So I see a y plus 3y's, that's going to give me 4y's. Well, now I see a negative 8 plus a 2, and negative 8 plus 2 would be negative 6. So I've simplified this part of the equation. Now I'm here. And so now to keep solving, to keep trying to get y alone, I'm going to get rid of the 6 by adding 6. They cancel, and I get 4y equals 96. And now, to get y alone, I just have to get rid of the 4. And I can get rid of it by dividing by 4. So those cancel. I get y equals 24. But again, they said find the measures of the angles too, so now we got to do that. So we need the measure of angle C. We need the measure of angle D. So for angle C, we've got our expression. It's just y minus 8. So if it's y minus 8, and if y is 24, then we're just doing 24 minus 8. And that leaves us with 16. So it's 16 degrees. Now the other one, D, we've got the 3y plus 2. So grab that, substitute in, figure out 3 times 24, so 72. And then 72 plus 2 would give us 74. And we can now check our work really fast. Remember, these things had to be supplementary. They had to add up to 90. So we actually knew that to find D, we could have just done 90 minus 16. Which leaves 4. That's yep, 74. So we know we're right. 74 and 16 do add up to 90. They're supposed to add up to 90. So I know my answers are all correct. Moving on, a couple more. So for number 9, it says find the value of x. We talked about this a little earlier. This little box means you're looking at a right angle, and right angles are 90 degrees. So again, we know that this expression and this 40, if those are the measures of these two angles, they must add up to be 90 because the whole angle is 90. So I can write my equation again where the 3x minus 4, you add that together with the 40 that you already had, and of course it would have to add up to 90 because we're looking at a right angle. So now we just solve. We're going to go negative 4 plus 40 because we combine like terms first. If this 4 is negative, even though it says you're adding, a negative 4 wants to take away from 40. So that negative 4 is going to drop us down to 36. So there. Now, to start getting x alone, we'll subtract away the 36. So that's gone. We now have a 3x that equals 54. And so now to get x alone, we got to get rid of the 3. So we'll divide by 3. That'll cancel it out. We get x equals 18? Yeah, 18. And this time it only says solve for x, so we don't have to do any extra math. Although, if I had asked you to find this angle, I'd like to think you would have just said, well, it's 90, take away 40, so it's 50. You know it's 50. But that gives us the opportunity to check our work, because if I take the 18 and plug it in here, I better get 50. So let's do that math and check. We're going to do 3 times 18, and then we're going to take away 4. 3 times 18 is 54. Take away 4, which is 50. So the fact that we got 50 both ways makes me feel good that we definitely did it right. So 18 is the answer. Okay, looking at these angles, you may recall that these angles share a vertex. They share a common ray. So these are a linear pair. And linear pairs are supplementary. So this time I know I can take the 6x minus 15. And I'm still going to add. I'm going to add the other one to it, x plus 20. And this time, because they're a linear pair, they must be supplementary. That means they have to add up to 180. So now we're doing algebra. I've got 6 x's plus another x. That's 7 x's. Then I've got a negative 15 that gets added to a 20. So remember, if you're taking 15 away from 20, that's going to leave us with a positive 5. So there's that whole side simplified. Now it equals 180. And we can solve by subtracting 5 from both sides. That gives us a 7x, which equals 175. So now divide by 7. That's going to be 25. And that's it. Again, we could check our work. I don't want to, but we could. We could plug in the x. 25 plus 20 is 45. We could plug in the x. What's 6 times 25? That would be 150. We're going to take 15 away from that. That leaves us with 135. And what do you know about these two numbers? They're supposed to add up to 180, right? Because they form a straight line. And guess what they do? 135 plus 45 does make 180. So again, I know that this 25 is correct. I can check my work. It doesn't take long. All right, now 11. It says ray BR is the bisector of ABC. Bisect means cut in half. So that means that BR is cutting this angle in half, that means this piece right here must be the same as that piece. That means we know that the 4x plus 6 is equal to, it's the same as, the 38. So turn that into an equation and then solve that equation. We're going to say the 4x plus 6, that has to equal 38. Because this angle got chopped exactly in half when it got bisected. Now take away 6 on both sides. So 4x equals 32. And then divide by 4. And you get x equals 8. Good news, everybody. We can check our work again. Let's plug in the 8. 4 times 8 is 32. 32 plus 6 is, oh my gosh, it's 38. So we did it. We made it so that these angles really are equal, like we needed them to be. So x is 38. That's it for that problem. I can see that I'm on page 14 of 14, so I'm done. Hopefully this video was useful. I do intend to keep putting videos like this out. So when you see them pop up on Canvas, watch them. Try to learn from them. I'll see you guys in class. Bye.